Tonda's next. Is this your presentation? Yes, it is. Tonda is the program manager for the floodplain mapping program inside of risk management, inside of North Carolina Emergency Management. She's been...
See my business card. All right, so I have got an hour and a half presentation that I'm going to do in 20 minutes. So we're going to talk fast here. The North Carolina Floodplain Mapping Program actually came out of Hurricane Floyd and Fran. I want to talk a little bit about the business case of why you develop a giant GIS application, because that's basically all it is. There is a database-driven SDE that provides the information that's shown in a map viewer. Hurricane Fran was in 1996 and caused a tremendous amount of damage. Hurricane Floyd was in 1999, also caused a tremendous amount of damage. North Carolina is very susceptible to hurricanes. That is an issue in North Carolina. When you're developing a needs assessment to actually solve a problem, the first thing you do is define the problem. The problem was not hurricanes. We actually have those. The problem was 51 people died, $3.5 billion in damages occurred, and 31,000 jobs were lost. And quite frankly, I looked recently, it was over $6 billion by the end with all the agricultural damage that was caused. So if you're building a GIS application, you need to define your problem first. People instinctively say, oh, it's a hurricane. The problem with Hurricane Floyd was it was a long-lasting, major flooding event that kept going on and kept going on and kept going on. So if you recall Matthew, it was a long-lasting, major flooding event that kept going on. What happened is, after you define your problem, you build a team. The team in North Carolina that came out of Hurricane Floyd was the cooperating technical state. We actually put together a group of people to coordinate a solution to solving the problems that came out of the flood. How to rescue people, how to make people aware what the problem was, how to make people know that they were in a flood zone, and how to make people buy flood insurance. The biggest problem was everything was paper, and the flood zones were so old that most of the people in the event did not have flood insurance. And let me assure you, if you do not have flood insurance after an event, the state and federal government will help you, but they will not buy you a new house. So you have got to actually be proactive about your insurance. So we signed a CTS agreement with the state, the FEMA, and a whole bunch of people that was on this list. And that was the team that defined what the problem was. So the problem we dealt with first was the old age of the maps. And how do you figure out who needs flood insurance and who doesn't? And the only way to do that is to have good base data. So that team came out and said, we're going to collect new LIDAR data for the entire state of North Carolina. It was the largest LIDAR project in the world at the time. It was $27 million. You could probably do this whole project now for far less than that. The technology at the time, it was delivered on CDs, which means the team said, when you deliver our LIDAR data, deliver it on the computer. And they installed a computer at the Emergency Operations Center with the LIDAR data in it. And then every time it was updated, they updated. And we ended up mapping the entire state of North Carolina. The delegation was given to North Carolina by FEMA. The mapping program does all the mapping analysis and engineering for North Carolina for the United States. Typically, FEMA can fund about 2 to 3 counties a year because they're dealing with the entire United States. We actually mapped all 100 counties with all new mapping. And I think the last panel was adopted about 4 years ago. And we're remapping right now. So the first FEMA process was map mod. Get the stuff off of paper, get it somewhere digital so you can see it. The next phase of FEMA that we're in right now is called risk map. This is analyzing the risk that is occurring in the area of the flood zones and all the other state hazards we are working on actively. The first thing we did was redo the storm surge, overland wave, and the coastal reef studies. The first statewide initiative, there was a moratorium on coastal mapping. The resolution of the input data to do coastal mapping was old. So we actually did not do coastal studies then. When we went to do the statewide again, the state of North Carolina took on the project to redo the storm surge analysis for the state of North Carolina. And that is being issued right now. Those original maps were done in the 80s. So you can imagine how the technology has changed since then. The second thing we have in North Carolina as an input data product is the CORS network. This is a massive time saver. This stuff is real-time downloaded. You can use it during the event. You can use it during the mapping. This is an amazing program that is coming out of an emergency management. We did a full statewide digital orthophoto collection because we had a statewide LiDAR data set. 1 year, they mapped, in 2010, 6-inch pixel resolution, the entire state of North Carolina. I will recommend that we never do that again because it snowed the entire year that year. But it is a baseline going forward. And now there's a statewide imagery project where there's a reoccurring imagery that occurs every year. Again, I told you base data is how you actually understand the problems that you are experiencing in the community. And we also are now doing a new LiDAR collection. So Hope can give you all the dirt about the LiDAR collection. And here's an example of that Geiger point count. This is actually going to be used for the engineering modeling going forward and the mapping going forward for risk. We collected statewide building footprints. Here's a picture, very slow, what the buildings look like. Somebody I'm sure has presented here, but it's over 5 million buildings in North Carolina. And those building footprints are tagged to know what portion of the structure is in the flood zone, and it's used for all the other hazards. We collected first floor elevations for every building in the 100-year special flood hazard area in order to see how deep the water would be in the building if there was an event. And we tied each building to the parcel information that's currently collected by every county. So every building has parcel information. And we attributed building information that either was field collected or came from a hazard, a hazardous run. And I'm showing you all this because all of that information is actually stored in a database at the EOC that our office uses. We decided with RiskMap we were no longer going to produce a paper product, that we were going to drive the entire program out of the database. So all of our maps are batch run straight off the server. Nobody goes in and draws lines at the state anymore. And it's displayed on the Flood Risk Information System, which is our web viewer. It includes all the engineering information. It includes all of the flood profiles, which are basically what we now call the water surface elevation rasters. Because we took that piece of paper that gave the profiles and we created a raster that you can point on any place in the special flood hazard area and you can get a water surface elevation at that point. It includes all the floodway data information and it includes all the survey information. This is amazing during a hurricane because you are sitting there at the EOC with a system that all of this is loaded on. And there's one source for everything, including all the risk products. So here's kind of what it looks like visually. You can click anywhere in the map. It'll tell you what zone you're in. So if you're people out in the field, there's a hurricane coming. You go find your property. You go, oh my God, I'm in a flood zone, or I'm not. Everybody in this flood zone should actually have insurance. They will argue about it all day long, but they need to buy it. We also show the 500-year event. And we show all the building information. So what's the depth above the first floor for these specific events? How many feet above the first floor will it be, or how many feet below it? We include all the LOMARs, which are letters of map change. So anytime anybody builds anything in a special flood hazard area, they have to do a letter of map revision. We actually receive in all of the engineering models and updates for those so that we can prep ahead of time and know if things were built in the flood zone. And all that information is also stored in the system. And then all the engineering models are there. And you can download those from the website. I'm just throwing that out. If you need an engineering model, they're available online. And they are the real engineering model. You get the HEC-RAS model. Or you get a note saying, call me, and because it's not there and I have to go find it for you. There is a download Frizz where you can download all this information. But I want to talk quickly about the preliminary mapping. When we decided to do preliminary mapping in North Carolina, we actually map not just the 1% annual chance, not just the 500-year. We do the 10-year, the 25, and the 50-year. There is a water surface elevation raster for each of those events. So you can actually get the water surface elevation based on an event. And you can get the flood information based on the event. And now I'm going to talk about Hurricane Matthew, because you needed all that prep for this. One of the key things in Hurricane Matthew was actually a program called Feynman. This came out of the need to actually inform people ahead of time during a long, slow flooding event what was happening to the water. So keep in mind, I got a water surface elevation raster for every occurrence of an event. I have a gauge sitting below the bridge deck. So you have a bridge and you put your gauge on the downside of the bridge so that all the debris does not knock it out on the way there. That gauge tells you how deep the water is there. You are literally running straight down that special flood hazard area and saying, here's how deep it's going to be when it comes downstream. And by the way, we work with the National Weather Service. It'll be there in 2 days. So if you're in this blue area, you need to move. I do know at the EOC this was a huge, huge benefit because they were literally moving teams of people ahead of the water to get them out of the way to try to avoid loss of life. And the one thing I do want to point out about special flood hazard areas is, and I don't know how much y'all know about this, I learned this during the event. The way you determine a floodplain is how much water can discharge through a stream. So from the top of the stream to the bottom, how much water can actually flow through this thing? And where it's impeded. Where did they build the bridges? Where did somebody build a building? Because there is a point where there's so much water coming through it starts backing up. And that's what the problem is. The special flood hazard area is a statistical probability based on, over the course of time, this amount of water has and can move through this stream. Potentially, there's a 1% chance it'll move through every year. The Hurricane Matthew event, you don't get like a 500-year storm. You get like a 10-year storm on this stream because it's discharging really fast. And you get a 1,000-year event on this stream because it's backed way up. And they're happening all over the place because every stream discharges like at a different rate. But they're all dumping it in those giant rivers that are going down to the ocean. And those were the ones that were getting bigger and bigger and bigger as all that water is moving through. And that's why I showed you we have all those events. So by stream, you can look at the gauge. You can say the water is this deep. It is closest to this event. This is probably where the water surface elevation is going to be. This is probably where people need to be aware. And we had all the engineering models in case we needed to go back in and do some on-the-fly engineering analysis, which they did there. And then Feynman has a scenario model. So at the specific gauges, they actually built in what are called libraries, where they did depth of water for every foot or every half a foot. And there was a bunch of presentations about Feynman here, so I'm not going to get too much into it. It's a live working system. You can go look at it yourself online. Because I want to talk about the city of Kinston. So here's some examples. So here's the special flood hazard area in the city of Kinston. They were watching the gauge in the water coming downstream to Lenore County and going, okay, here's your problem. If you live right here, you got a problem. You need to get out of the way. We actually could color code by building where the first floor was. So anything red was at a greater risk of getting flooded because the first floor was below the water surface elevation. So those are risky places to be in. And we could also say for each building what the depth above the first floor the water would be at. But we're using these general, you're in one of these parameters. You're in one of these water surface elevations, the closest one to where you're at. This is what Kinston actually looked like. The other one I want to talk about is Fair Bluff. So Fair Bluff is a small town in Columbus County, and I was working at the EOC the night that Fair Bluff flooded. So people were all excited. They were watching FEMA. The rivers were going down. The gauges were dropping. But people forget that water is water. And as it moves downstream, it's going to move into the lowest point. And Fair Bluff was lower, even though everything was going down, even though the rivers were going down. By the time it hit this point, Fair Bluff was still below the water surface elevation of the water. And it flooded over this train track into Fair Bluff and filled it up like a bathtub. And it kept filling it until it equalized the water in Fair Bluff with the water in the river. And then when the river, as the river went down, the water in Fair Bluff went down. I do point that out to people because you have information, but you actually have to use it in a GIS system proactively. You can't assume that, oh, I've got a picture and this is a picture in time. You actually need to think about it in terms of all the other GIS you have around it. If you have gauge information, you can you can make better predictive analysis downstream on what's going to be impacted as the water starts moving through. And this is the town of Fair Bluff before Hurricane Matthew. And this is the town of Fair Bluff after Hurricane Matthew. And that's a real small community that had a lot of issues. And here's another picture. So, did I use all my time? I got a minute left. See, I can't believe I did that. That was a really big crash course. I will follow up and say my four main factors are: if you're building a GIS and you're building a business case, really define your problem. The state of North Carolina did an excellent job defining the problem with Hurricane Floyd because Hurricane Matthew was everything that has been done since Hurricane Floyd paid off, sitting at the EOC for Hurricane Matthew. Everything that every community contributed, because this is not just the floodplain mapping program. This is every county, every state agency, every local government helps to contribute the massive amount of data we have that allows us to have programs like this. Say that again. He's asking if FEMA will have more temporal products. I can tell you our office is talking about this because we're already looking at doing inundation mapping. So FEMA, and I don't mean like the flood zone, I mean on the fly. So you're actually mapping on the fly the inundation path. Because like I said, these are not frozen in time events. These are changing as they move. I know there's a lot of interest in FEMA. I will say that unfortunately for FEMA, we have every piece of engineering data that was ever done in North Carolina. We have all the history. It's harder at the national level because the base information you need to do some of this is not available. But, technology improves every day. But I know there's a lot of talk about it.
I was wondering if you took an event like Matthew and compared your delineations of your flood zones and looked at Matthew and tried to reconcile to make sure that you were looking at that.
We did. We actually sent them. Oh, I'm sorry. They were asking if we took the actual events that occurred during Matthew and compared them to what our predictive analysis was. A lot of what recovery is doing is looking at the damage piece of it. I only spoke to the mapping piece, and they're using this to truth the damage assessments that we had during the storm. and we have high water marks. But we also had survey crews go out there and take pictures and GPS locate where the water was in some locations. Joe's going to answer that question.